Today our topic is about the bridge rectifier. Bridge rectifier is actually the full wave rectifier, and its working is it convert input AC wave into the positive ripples of AC wave. Actually, it working is the same as the center tape full wave rectifier, which use the center tape full wave rectifier use the center tape transformer with the 2 extra diode, but the bridge rectifier use the simple transformer, but with the 4 diodes. Okay, so 4 diodes. I will discuss what are the difference between the. Today I will discuss what is the difference between the center tape transformer and simple transformer used in this bridge rectifier, and also explain two circuits which are the exact which are actually the same, but actually the same but look like a little bit different. Okay, I will draw a both circuit and their equivalent diagram and their working. Okay, so firstly I am drawing the this first circuit for a bridge rectifier. It has 4 diode and 1 load resistance. Okay, the load resistance is connected from the center. Okay, these are the 4 diode connected in this way. Edge is representing edge type triangle type part is representing the P, and straight line type is as representing the anode part of this diode. Okay. N type of this. The other equivalent diagram is this. Other circuit is this. The same diode order will be the same as used in a circuit 1. But a load resistance will be managed in this way, and it is also used a simple transformer as used in circuit 1. Okay, now I will explain what is the actually it will be divided into 2 parts. This is a fig A represent the first circuit diagram, and fig B will be represent the second circuit diagram for bridge rectifier. Okay, so I will draw equivalent circuit and working of these 2 circuit diagram that and we will get the working is the same, and this edge part will be represent the P part of diode, and straight line will be represent the N part of diode. Okay, now I will explain the these 2 type of transformer. What is the difference between center tape transformer and the simple transformer? Okay, this is a diagram for center tape transformer. It is tapped from the center, so it is grounded from the center. Okay, and if the AC wave is coming as an input wave, alternative current or AC wave is coming as an input wave, then this center tape transformer will divide this wave into two wave signal with the balance, because it will be reduce the amplitude of outgoing wave, okay, because it is dividing it into the two wave which have opposite polarity. Mean if it is a positive at first terminal, then it will be a negative on a second terminal of this transformer, okay, at output, okay. And if the at time the first terminal is negative, then second terminal will be a positive. If first terminal is a positive, then second terminal will be negative. If first terminal is negative, then second terminal will be a positive. Because it is dividing the input wave into two wave, so output will wave of both terminal have less amplitude than input wave, and because the output wave is the input wave is dividing into two waves. Okay. So these two colors are representing the green color is representing the output wave at terminal 1, and green is representing the output wave of center tap transformer for terminal lower terminal, and green is representing the upper terminal, and uh, purple or red type wave is representing the output wave at a lower terminal of this transformer, okay. Okay, so this this is used in the previous lecture, okay. For in bridge rectifier we use the simple transformer. I will explain about the simple. In simple transformer, there are two type of simple transformer. It's one is a step up transformer and step down transformer. Step up increase. This is a center tape transformer, okay. Center tape transformer. So center tape transformer convert one signal into two signals, okay. One is representing by green and one is in purple, okay. Both are 180 out of phase, okay. 180 phase. Both have a 180 phase difference, okay. Mean the polarity is in simple transformer. The input wave will be the input wave. Sorry, if there is AC wave is coming, then output wave will be also a AC of the same shape, okay. If that is the step down transformer, then the amplitude will be decreased. If that is a step up transformer, then the amplitude will be increased, but the shape will be remain the same as the AC wave, as input wave. Mean this wave, the signal will be not divided into two signals in this simple transformer, but in the center tape transformer, the single input AC wave is divided into two AC waves, but with the opposite polarity. Mean you say that phase difference equal to 180. That is the actually the difference between the center tape transformer and the simple wave transformer. Actually, we in bridge rectifier we are not using the center tape transformer, so I will shift it into the toward the other side. Actually, we need the circuit diagram of the bridge rectifier. Now I will draw the input wave out. I will draw the input wave, output wave, and the equivalent circuit diagram for these two circuits of the bridge rectifier. Okay. Okay. Okay, now I will draw the equivalent circuit, input wave, and equivalence working diagrams, and output wave for different different cycle of this wave. Actually, the input wave is AC wave for these two circuits, as I've already explained. 0 pi is a half cycle. At 2 pi, the cycle will be complete. Mean one wave will be completed, and this will be defined as a one cycle. Okay. Because one cycle will be completed, so its period is 2 pi of AC wave. You can see the AC waves for used in Pakistan in our home is sorry, not 220. By mistakenly I write the 220 is voltage, 60 cycle per second, means 60 hertz. Okay, these are the efficiency of the our AC, and voltage will be 210 to 220 voltage. Use these are the AC waves used in our home. Okay, in Pakistan and some other countries like Europe. In America, I think mostly countries, world countries, we use the AC wave 60 hertz and voltage of 210 to 220. But in America, we use the 110. America is only the America or Canada. In Canada, we use the voltage 1020. Okay. Now we will draw the equivalent. We will try to understand its working by discussing the different part of input wave of this different part of input wave of input AC wave. Okay. This is the input AC wave. Okay, because input AC wave have a two part, T1 and T2. T1 is from 0 to pi, that is a positive part, and T2 is a negative part, and that is from pi to 2 pi. Okay, this is T1 0 to pi, and for T2 input wave is AC wave is pi to 2 pi. as you may observe from the diagram. Okay. This is for first first row represent the T1, the time input wave for time 0 to pi. Okay. But second second row is representing representing for input wave 42, okay, which is a negative part of the input wave, AC wave, and it is from pi to 2 pi. Now we firstly draw the equivalent diagram of the fig A, equivalent diagram showing the working of the fig A, circuit A, okay. So I will represent. So this is a fig A. Equivalent. Now I will draw the equivalent diagram for fig A. For if I'm trying to resizing it so that we can properly easily may understand this diagram. For fig A, the equivalent diagram will be diode D1 will because for positive for T1 the input is a positive positive part of ripple, positive ripple. So this is a positive ripple from for T1. This is a positive ripple, okay, a positive ripple part, that is 0 to pi, okay, for T1. And T1, that is T1 is from 0 to pi, and the ripple is increasing its maximum value and then decrease to 0 again, okay. So for this part T1 diode D1 will be forward wise because this is a positive, so P will at positive P part of diode D1 will be positive, and the end part will be a less positive, and so that will be short circuit, but that will be a short circuit, okay. But for D2 the end part will be a positive and P part will be a negative. That means it will be D2 will be behave like a reverse bias and open circuit, okay. So for 0 to pi, because it is firstly increasing to maximum value, and then it at the center it will approach to maximum value, and at the center of T1, I mean at pi by 2 it will have a maximum value, and then it reduces to the 0 to pi, at the pi, but it will remain for positive ripple for T1, okay. Always remember that negative doesn't mean the negative, but negative mean lower value as compared to positive value. I mean, if 3 is a positive value and 2 will, if you have a 2 potential value, 3 and 2, then 2 will be defined as a positive, 3 will be defined as a positive, and lower value will be actually lower. Negative mean lower value, okay. So diode D1 have a higher value at P, and D2 will be as a will be behave as open circuit, because n part of which is straight line, represented by straight line, will be at lower value, n part will be a higher value, so and p part will be a low value, because AC incoming wave is a positive. So D2 will be treated as an open circuit, and no current or voltage will be passed through, no ripple will be passed through the diode too, but instead from the RL, and then it will move toward the D3. Why it will not move toward the D4? Because the current coming from the transformer, that for T1 is a positive, and the P terminal will receive the signal which has dropped from the load resistance. Okay, so the P side will because P side is receiving the signal which dropped due to the which dropped the value due to the load resistance, have lower value, but N type will receive the higher value which is coming directly from the transformer. Okay, so N part of so Beta part will be at lower, and N part will be higher. So this will be also a reverse or open circuit for T1. Okay. Okay. So current firstly pass from D1, then load resistance, then D3. Okay. So equivalent diagram will become this way. Firstly, D1 will be treated as short circuit, so current will ripple will pass through from this, and then from then it move toward the load resistance. But it will after passing through the load resistance, it will not move toward the P4, because P terminal of P4 is receiving the signal which is dropped due to the load resistance, which comes from the diode, then from the load resistance. So that's this means the value will be dropped. So that will be D4 will be treated as a reverse bias, but D3 will be as a short circuit forward bias, and so current will so ripple will be passed from the D3, and this end circuit then it goes to the back, so that circuit will be completed. Okay, so this will be equivalent circuit diagram for T input wave, that is a positive for 0 to pi. Okay, D1 load resistance, and then D3. Okay, D3. Now I draw the circuit for time 2, which is from pi to 2 pi, and that is negative part of AC wave. Okay, this is 0 to positive, and 42 that will be go down 0 to 2 pi, pi to 2 pi, that is negative part, and at the center its value will be a minimum, and at pi it is 0, and at 2 pi it will be a 0, but at center so for this purpose, because this is negative part, so for D1 it will be for D1 it will be D1 P will face a negative, mean lower energy, no ripple, negative ripple. So P will face a negative, and of diode 1, and N of diode will be a reverse bias. Negative, positive. So it will be reverse bias, but D4 will be a positive, because incoming wave is a in negative ripple, negative part, so n will be a more negative due to negative part of input wave, and so n is connected with the negative, and uh, p will be connected with the positive for diode 4. So current diode will be treated as a forward bias, and then it D4 D3 will be as a reverse bias, because D3 because P will be face on P terminal of a diode 3 will face a negative input, but so P positive will be connected with the negative and negative, so that will be open circuit, so current will be passed through the load resistance, and from D1 D2 D1 is negative part is the receiving the negative voltage, which is lower value, which have a lower value and drop due to pass after passing through the load resistance. So negative part will be of diode 1 will be less negative than the P part, because P part of diode 1 is facing directly from the negative ripple of coming from the transformer, okay, without any droppage. So that's mean so it's mean n part will be a more negative, so the current will pass through the D2, okay, not D1. So firstly it will move from the D4, then load resistance, not D4, firstly it will pass through the D4, okay, and then it D4, and then it load resistance, and then from it will not pass through the D2, because and but it will pass through the D2, and is in this way the circuit will be completed, okay. So the equivalent diagram will be like this. I may draw it here. This is coming incoming wave. This will pass through the D4, because D4 will behave like a short circuit, but then from the load resistance, and then from load resistance, it will move toward the D2 will be as a short circuit, so it will move from the D2 to back to the cell. So that so this will be the equivalent diagram for the fig A, or circuit A1, circuit A. T for T1, which is 0 to pi, and for T2, which is pi 2. This is G4, and this then it will pass from the load, and then D2, diode 2, okay. Now I will draw the equivalent circuit for fig B. These as I explained already. If we try to understand the circuit working of the circuit, circuit 2 mean fig B, the diode for circuit 2 diode D1 behave as a forward bias for T1 positive wave, for T1 which is 0 positive wave, so D1 will be positive, but D2 because it is a positive part, so D2 it will not it will pass through the load resistance, then it will move from the D3, not D4, as I explained already explained for the circuit 1, D1 to D3, okay, not D4, as I have already explained, that the voltage, incoming positive part of incoming wave after passing through the load resistance, it will be dropped. Some value will be dropped. So the P part of D4 will face less positive because its positive part will be dropped due to the load resistance. Okay, and but N part of diode is receiving the signal directly from the positive part of AC incoming AC wave, so it will be more positive. So D4 P part of the D4 will be a less positive, and N part will be a P part will be less positive and part will be a more positive. So it mean it will be treated as a reverse bias and it will be treated as open circuit. Okay, so current will be so input signal will pass through the D3 instead of D4. So firstly it will come and it will pass through the D3. Okay, then load resistance RL, then it move toward the upward. Okay, and moving toward moving toward D4, it will move toward the D3, because D3 will be treated as a forward bias or a short circuit, but D4 will be treated as an open circuit. Okay, so it moved toward the D3 and then back to, so this in this way the circuit will be complete. Okay, and so this D1 and then D3. Always remember the current will not pass through the ripple will not pass through the D4 because the positive part of ripple is dropped due to the load resistance, and so P part of diode will face a less voltage due to the dropping across the load resistance. Okay, and so it will pass only the diode 3, as I already explained in the circuit diagram of Fig A. Okay, so it will pass through. Okay, now for negative part of negative part of this negative part of this current will pass through the D4 and then it move toward the load resistance and it will move toward the D2. It will not pass through the D3 because it is the negative part, and so P will be connected with the negative, so it will pass through the diode 2, not diode 3. The same reason I have already explained in the because the voltage will be dropped. N part of the diode will be face a drop voltage which is dropped due to passing through the load resistance. Okay, and P part will be higher at lower because it is not dropped, and it incoming wave is have a negative part, so it will be a more negative as compared to N part of diode 3, because a negative part of ripple will be dropped. Value of negative part of ripple will be dropped due to load resistance, passing through the load resistance. Okay, so equivalent circuit for T2 equivalent circuit will be like this. like this. It will pass through the firstly pass through the D1. No, sorry, not pass through the D4 because it is negative 0 to pi to 2 pi. So because it is a negative pulse for D2 T2, so it will firstly pass through the D4, then D3 will be a behave like a reverse bias open circuit because negative part, so P will be a more negative of D3 because it is facing negative part of the P part of the D diode will be negative part, so it will be open, so current will pass through the load resistance. Okay, then it will face D2 and D1, but it will pass through the D2 because D2 will be behave like a short circuit because voltage will be dropped after passing the value of voltage ripple will be dropped or voltage will be dropped after passing through the resistance load resistance R. So and part of the diode 1 will be less negative. Okay, so it will be open circuit, so it current so ripple will pass through the D2 which is behaving as a short circuit. So firstly D4 incoming wave will be incoming ripple firstly negative incoming ripple will firstly pass through the D4, then after passing through the load resistance it will move toward the D2 and D2 will be forward wise, and then it will move toward the 41. It will move from here 42 ripple will be moved this way. Okay, so these are equivalent circuit diagram for the other fig B. Okay, now I will draw the now I will draw the output wave for these two. So that will be the same for both the circuit. For T1 output for T1 which is positive part of the ripple, for T2 which is negative part of the input ripple, this output will behave like this. Okay, for positive part of the input ripple 0 to pi output of bridge rectifier for diagram A, for diagram A, fig A, as well as for fig B. Okay, so this is equivalent diagram for both, so output wave for both circuit, and this will be the same. The negative part of the T2 will be converted into the positive ripple of the positive ripple as the output. Okay, so if we combine, so the combine the load the load resistance will experience the combine effect at T1 and T2 when we combine the T1 T2, because at time T1 the positive ripple at T2 is also positive ripple, so for complete cycle it will have two positive ripples. Okay, so ripple will be the ripple will be doubled. Okay, positive ripple will be doubled. So if so positive ripple will be doubled at for T1 it is also positive, for T2 it will be also positive. It will be so negative part of T2 will be converted into the negative ripple of the T2 will be converted into the positive ripple. So at the output we output for one complete cycle 0 to 2 pi we get two positive ripples. Okay, from the full wave bridge rectifier. Okay, This will be the result. Output for a complete one cycle T, that is divided into two parts, T1 and T2, 0 to 2 pi. Now reason, as I have already explained, due to the when explaining the circuit 1 and 2, why the current is not passing, for T1 the current is not passing from D4. So now I will be explain why the some diode will be treated as open and some diode will be treated as a reverse bias, and some is a forward bias. Some are a short circuit and why some are a open circuit, behave like a open circuit. Okay, now I will explain it. Okay, what are the reasons? Now I will explain the reasons. Current will pass through D1 41. Why the current will pass through the D4, D3, not D4. Okay, why the current? Firstly, I will explain 41. Why the current will pass through D3, not D4. Reason is P part of D3 is reverse will receive, sorry, P part of D3 will receive the dropped current of positive part of input wave drop current passing through the passing through the load resistance. Okay, so P part of D3 receive the positive input AC dropped reduce, sorry, P part of D3 receive the input drop is positive part of drop low positive because dropping due to the resistance, receiving the positive part of input wave after dropping the resistance R. But N is receiving a more positive part because it is receiving directly positive part of AC wave, okay, without any dropping. Okay, because it is directly connected to the input AC wave. So connected to P of D3 will less, so P of D3 will be less positive because it is receiving the signal which is dropped after passing through the load resistance, but N part of D3 will be more positive, okay, because it is receiving the signal directly from the input wave. So this will behave, so this D4 will behave like a reverse bias. So it will behave like a reverse bias. D4 will be a, so sorry, that is not D3, that is D4, okay. So D4 will be for both circuit, okay. Now we will move toward the for time t2. What will be output? So D4 will behave like a reverse bias and open circuit. No current will be passed through the D4, but it will pass through the D3, which behave like a short circuit. So D4 will be reverse bias and behave like a reverse bias and behave like a open circuit. Now I will explain for time t2. Current will pass through for D2 for T2 pi to 2 pi. The current will pass through for time T2, which is negative part of input AC wave for pi to 2 pi. Okay, that is the negative part of input AC wave. Okay, so for this part, current will pass through the D2, but not D2, but not D1, because N part of D2 N part N part of D1, sorry, not D2, D1 will face for D2, okay, D1 will face negative part of input wave after dropping dropped through load resistance RL. So less negative because it is dropped due to load resistance. So less negative, so less negative is N part of D1, but P part of D1 is P part of D1 will facing directly negative part of input wave coming from without dropping, okay, direct input without any dropping. So D1 will be, because its N part is less negative and P part is more positive, so that will be a reverse bias. Okay, and behave like a open circuit. Okay, now note is completed, and this is all about the bridge rectifier. Okay, so this was input wave for T1 and T2. The input wave, I have divided it into two parts, 0 to pi positive part, pi to 2 pi negative part. So this fig A is representing and fig 2 is equivalent of fig B, and this will be the output waves for T1 and T2, and that will be combined result of and at output we will positive ripples only. Okay, and that's the same as, exactly the same as the center tape full wave transformer. Okay, so why current is passing through the D2 not D1, I have explained each and everything for T2